So my name is Jimole Arnold, software engineering student, and this is my project, an automated police signal. In our communities, you find that the police is so distant from the people, whereby police gets to know of the crime very many hours after the criminals have fled the crime scene. And with the development of this model, on hearing any scream of a person in need of help, the police will be signaled at that instant, as this will help curb crime. This is what I'm looking at. I'm trying to curb crime in our communities. I'm trying to work on the response of the police to all these crimes that keep going on, for example, in the nights. Yes. Now, how will artificial intelligence be applied? This artificial intelligence will be applied in this way that AI will be able to differentiate between any normal loud noise and a person screaming for help. There has to be a difference between those two, and AI has to be able to do that. As it has to keep doing it has to keep making some predictions until when it hits the right thing. Then AI, on hearing the scream in need of help, it will send police a signal message. AI shall also provide the most affected areas over a given period of time, depending on the number of cases that there have been in that area. Using machine language, the police will be able to retrieve any data needed, either on the trends of criminality or anything else. Then the type of data, those are three: numeric data, which is basically exact numbers; text data, where we use words; binary types, where we input audio. Then we have differences between supervised and unsupervised learning. Under supervised, algorithms are trained using labeled data. Under unsupervised, algorithms are trained using unlabeled. Under supervised, model predicts the output. Under unsupervised, model finds the hidden patterns in data. Under supervised, input data is provided to the model along with the output. In undersupervised, only input data is provided to the model. Then under supervised learning needs supervision to train the model, yes. Under unsupervised learning does not need any supervision to train the model. Then unsupervised learning can be characterized in classification and regression problems, while the said learning is classified in clustering and association problems. Supervised learning needs supervision to train the model, while unsupervised learning does not need any supervision to train the model. Go to the next one. Supervised learning techniques. One, we have random forest, this is where a collection of uncorrelated decision trees are merged to reduce variance and create more accurate data predictions. I use it in my model because it creates a large data set of different sounds, which increase its chances of choosing what is right. Yes, that is AI. Then K nearest neighbor. This is rated among the most accurate, but this is its explanation. Algorithms store all the available data and classifies a new data point, basically basing on the similarities. And now I compare this to my model. I put this into my model, and this is how I'll be able to use it. This algorithm assumes that similar data points can be found near each other. Therefore, in our system, all sounds similar to screams are first grouped together. Yes. Then Slide 7. Unsupervised learning techniques. We have the hierarchical clustering and the anomaly detection. Anomaly detection is identifying data points in data that don't fit the normal patterns. Simple as that. As you hear, anomaly. Yes. Then hierarchical clustering. Algorithm builds clusters by measuring the similarities between data. This is used in the way that the model categorizes different sounds from the public into, yes, that is it. That is it, different sounds from the public into clusters. Yes, that is it. Then 8 technical challenges. We have data security and storage, whereby projects heavily rely on availability of large amounts of data, and in case this data lands in the hands of the dark web guys, the dark web, definitely there is a problem. And since these projects are dealing with large amounts of data, therefore data is being generated, more data is being generated, and the more users have access, the most likely. Then infrastructure, use of outdated infrastructures, applications, and devices to run this project, as management often gets scared of the expenses. Then you also have determining the right data set. It's possible to configure AI algorithms to control the flow of quality, and the natural data. Then we have the solutions. Use of outdated infrastructure can be solved by seeking for funding. Determining the right data set can be solved by having a trusted source of relevant data. Then data security issues can be solved by using the only data type necessary to create the AI, and the data should be kept secure and unlimited for as long as it is necessary to accomplish the purpose. All right, then we go on to 10. Differences between accuracy, recall, precision, and F1. Accuracy has the following definitions: number of correct predictions plus total number of predictions. Recall is a measure of how many relevant elements were detected. Precision refers to the quality of a positive prediction made by the model. F1 score is a measure of a model's accuracy in a data set. It is used to evaluate binary classification systems which classify examples. All right. Then we have the AI evaluation metrics. Metrics mean measures. Accuracy, which simply measures how often the classifier correctly predicts. And I've given you its method, which is true positive out of true positive plus true negative, all multiplied by 100. Then I also put the confusion matrix. Is a performance measured for the machine learning classification problems where the output can be 2 or more classes. This is where we further understand that our model can have the true positive, true negative, false positive, and false negative for results. Then I went further to give you an example. I give you a method for Formula 1, and that had happened. Yes. Then these are my references. Thank you.